Hello there, this is KP the Math G here. I thought the way I would do these next few lessons, and I have quite a few lessons prepared. I've got three of these. Actually, it's probably going to be done in uh, two parts each, or some of those I might can do all at one time. I don't know, but this one's going to be two parts. It's got four parts to it. I'm going to do A and B this time, and then B and C, or C and D the next time. But before that, I'd like to say that I want to do some other concepts. That's probably going to get into the BC area if you are taking AP Calculus BC, and that's for those. But now it doesn't matter if you're an AB student, you might want to look at some of this, and if you're a calculus student, you definitely want to look at this as well. So I just want to try to spread the wealth for both the AB and the BC students as well, and those who are in a regular calculus class, you might need some of this as well. So anyway, let's go ahead and look at this. This has to do with a car traveling in a straight line. And I guess I'll just go ahead and come out with this. And if you look at the graph, you have V at t is in meters per second. This is the graph of the velocity. And it is, the time is in seconds, so we have velocity here, okay? And the first question of the two that we're going to answer today, okay, so A part, we want to find out, let me see what A part is. Alright, we want to interpret what this means. Okay, it's sorry, V at t dt. Now you're taking the definite integral of V at t. What does that mean you're doing? What are you finding? Yeah, that's right, you're finding the area of this, but now what does that really mean? Okay, it means that you're finding distance, aren't you? How far did you go? We don't need to put absolute value bars around this because all of this is above the t-axis, if you will. Okay, we don't have anything below that. Alright, so this is actually total distance. How far did you go in this interval from 0 to 24 during this period of time? Okay. Alright, so let's see here. If we look at this, there's about two ways to do this. We could divide this up into two triangles and one rectangle, if you will, or we could just do this whole thing as a trapezoid, and I like to do that because that way I don't have to do three different things here, although it may be easier for you to go ahead and divide this up right here like this, and then come down here to 16 here, and then evaluate. We know the areas of triangles are base times height divided by 2. The area of a rectangle is base times height. So that would probably be easier for you. Then you could sum up all three of these and you could have your total distance. Okay, here remember that on a trapezoid, that the area of a trapezoid is base 1 plus base 2 divided by 2, and then times the height. Alright, so let's keep that in mind. Base 1, that's going to be your parallel sides. That's what base 1 and base 2 are. The length of base, we'll call this base 1. That's going to be 16 minus 4, which is 12. So this is going to be 12 plus, the bottom is from 0 to 24. So 24 divided by 2, and then times the height of this is going to be 20. Alright, your y value is 20. Alright, so 12 plus 24 is 36. 36 divided by 2 is 16. Oh no, I'm sorry, 18. But anyway, we can do it this way. And I like to just go ahead and say 2 goes in 20 10 times. And then 36 times 10 is 360. Now the question asked, write this down in appropriate measure. This is in meters. Alright. So the car traveling in a straight line traveled a total of 360 meters during the time, okay, like this, during this time t between 0 and 24 seconds. Okay, that's how you do A right there. Just keep in mind, everyone, when you take the antiderivative, or if you take the definite integral of velocity, you're looking for the area, which means you're looking for how far. Remember, this is in meters per second, so when you take the antiderivative of this, it's in meters now. Okay? You're actually multiplying meters per second times second times time, and that's going to be in meters. Okay, like that. Okay? Alright, that's part A. Let's see if we can erase this and put part B up there. Okay, let's try that. So anyway, bear with me just for a little bit. Alright, this one can be a little bit tricky. Part B is asking for a couple of things. Now, I think they're saying, alright, we want to find if it exists. If it exists, we want to find what V prime at 4 is, and after we get through that, V prime at 20, and we want to use the appropriate units. Now, what are you finding when you find V prime of anything? Now, this is acceleration. The units for acceleration would be meters per second squared if we find that this exists. Let's start with V prime at 4. Let's just do a little dotted line from down here. Now, what's interesting about this is that V prime at 4 is in a corner, isn't it? It is linked to this line that has a certain slope to it. And that's what this is. This is the slope of the tangent line to whatever curve we're talking about. Okay? In this case right here. Alright? This is a slope here. What's this slope here? This is another line that it joins to right here from the right side. It joins to this point here, 4, 20. Okay? And this slope here is 0, isn't it? So we know that from the right, the slope is 0. This slope is certainly not equal to 0. And remember that when you practice or you want to find out about continuity, whether something is continuous or not, the slope, the limit from the left side must equal the limit from to the right side. Okay, that was one of the qualifications for it. Okay, so let's see. So if we say, let's look at the right side. We can say the limit All right, as t approaches, all right, I'm just going to abbreviate this, approaches 4 from the left side, from the right side equals 0. All right, equals 0. The limit, in like manner, as we might say, as t approaches, all right, 4 from the left equals something, but it's certainly not 0, is it? All right, so if we just took the slope, this is the slope here. This would be 20 minus 0, y2 minus y1 over x2 minus x1. Well, that's 20 over 4, which is 5. And because the limit from the left does not equal the limit from the right, and there's probably a better way to write this out, then the limit, then we might say, or we are going to say, that v prime at 4 does not exist. Okay? And because it does not exist, v is not differentiable at t equals 4. Where else is it not differentiable? Find another corner. Yeah. 16. The slope is 0. This slope is something else. It's certainly not 0, is it? So it's not differentiable in 2 places. And I think when you get the C part or D part, I can't remember which one it is, you're going to find that you're going to need to know that. Okay? This slope here is equal to 5. This slope here is equal to 0. So this at 4 does not exist. Okay, so it's not differentiable, and so we just simply cannot determine really what the slope, or what this v prime at 4, this is the slope at 4. I don't know what it is because this is stuck in a corner here. It belongs to both of these segments here, doesn't it? Okay, so does not exist here. Okay, not differentiable. And that's what you got to do. You got to say that the slope from the left side is 5, the slope from the right side is 0. And you have to really say that. Okay, I'm going to erase this because we need to find v prime at 20, and let's see if that one exists. I want to know if it does or does not. Now remember, all we're doing is finding the slope here, because this prime means what is the slope here? V prime at 20. Okay, right here. It comes up somewhere. Okay, give you a hint, it's 10. Okay. All right. Well, so anyway, we're looking at the slope of this. So let's try it. All right. So that's going to be equal to, let's see, 20 minus, oh, this is, by the way, 24 comma 0, so 20 minus 0 over 16 minus 24. And we have a definite slope here, don't we? This one does exist, okay? This one's going to be 20 over negative 8, which is equal to, let's see, 4 goes into 25 times, 4 goes into 8 2 times. So we need to get our units right. V prime at 20 is A at 20, which is equal to negative 5/2 meters per second squared. There it is there. You're looking at the slope right there, at that point there. Okay, that's what we're looking at. This slope is negative 5/2 meters per second squared. And that's really what you have to do there. Okay, maybe, yes, maybe we might have time to deal with the C part of this. Okay. That's mainly, I just wanted to get this, especially the V prime at 4. Anytime you see the velocity equation, you got this piece slanted and this piece straight across, or even if it's slanted a different way, that's slow. That does not exist. Alright, this is where you have to find that limit to the left and the limit to the right. Okay, enough of that one. And then this one here was not in a corner, it was right here on this line, which contains this slope here. Okay, so that's what we had to deal with there. Let's see if we can squeeze in C part. I don't know if I can get D in, but I would love to get C part in. Okay, man, going a little bit faster than normal. Okay, but that's good. That's good for me, because actually I tried to do this video, and all confession, I made a blunder out of just, I was just not totally ready for it. So I just sat down and prepared it a little better, and just kind of got my ducks in a row, if you will, on that. And this turned out way better this time around. And that's what you need to do if you're going to teach this kind of thing. You got to put everything together. Alright, so let's try this right here. We're looking at A at T now. A at T, and we want to find all piecewise functions that's related to A at T. Piecewise. We want to make a, well, what is it trying to say? Let's see. Write a piecewise function, yeah. Piecewise function. Well, an A at T is mainly the slope of the tangent line. So we got two of the slopes. And so here's how it works, okay? Here's what you got to do. A at T then. And that's actually B prime at T, what we just looked at a while ago. Alright, now it equals. Alright, I've got this piece right here. We found that slope is equal to 5. So it's 5 if T is between where and where? Alright, T is between 0 and 4. Is that right? Yeah, as long as we're between 0 and 4, we're okay there, aren't we? Now we got another one. This line here is another piece, and it goes from 4 to 16, doesn't it? Alright, I see it right here. It goes from 4 to 16. Alright, so let's see. So that tells me that T is between 4 and 16. What is the slope? The slope is 0. Alright, the slope is 0. There we go, right there, isn't it? We have one more piece here. I want to say that we may have already found that one as well. Remember, this is 24, 0. So let's see, or we could do rise over run if you wanted to. But this is, if you want to, 20 minus 0. The slope is 20 minus 0 over 16 minus 24. Yeah, minus 24. And that's going to be 20 over negative 8. Remember, that can be reduced. 4 goes into 25 times, 4 goes into 8 2 times, but so negative 5/2. Okay, if t is between where? Now that's right, 16 and 24. Very nice, isn't it? See that? I don't know if I'm going to be able to talk a little bit. I want to talk a little bit more in detail about part D, so I'm going to probably reserve that part D for another lesson, because knowing my old camera there, that thing has a tendency to say, okay, time's up. And I know that time's up because right now, well, it's not quite up now because I have a blinking red light. As long as that thing's blinking, I'm good. But if it stays on and it doesn't blink, I know that the show is over. I don't have time, you know. If my show is over, I don't have time to do my my clap at the end, you know, like that. Everybody who's seen me, I do one of those signature claps at the end. I hope you like that. That's just me having fun with you guys. I appreciate it. It's kind of a sign of appreciation for you. Okay. Again, this is KP the Math G. I hope this has benefited you very much in doing this. Remember that we have found on A part the actually it's not antiderivative, definite integral of b at t. That's this area here. And we did a trapezoid area for this here. On the second part, we had to determine whether b prime at 4, so that's that slope. Can't determine what it is, can we? Okay, well, at 4, but we could here at 20, and that was b part. And then the c part here was make out a piecewise function for a at t. And that's all we're dealing with is slope on that. And then putting these proper units here for that. Okay, intervals for that. Okay. So anyway, take a deep breath. KP the Math G is going to be all right. KP the Math G, just saying to you that if you would like to subscribe, if you haven't done so, please do so. Please subscribe. Yeah, of course, if you don't, that's okay. You'll learn this, it's all right. But I mean, you don't have to necessarily subscribe, but it would be nice if you did. I have now, let's say this will be the 97th video. So I have several videos. So it may be worth your while to subscribe. And then if you want to hit that like button, that'd be nice. It puts a big smile on KP's Math here. Just a nice big smile here to know that you liked my video. And you may not have liked it, but if you don't, then tell me what I could have done better, because I want to make you better. And then finally, if you would like to make a comment, that would be all right too. Okay, well anyway, this is KP the Math G signing off for now. You ladies and gentlemen have a great, great day.